Well, we're going on a little road trip here. People ask me where I get my steel, and we're getting stuff from Craigslist today. So we're driving up to Lebanon, New Hampshire. Hopefully come back with a lot of steel. Getting up into the mountains now. We got about an hour to go here to get home, and then I'll show you what we got. But these Craigslist things, about half the time they work out good. A lot of times you show up and it's like either been picked through, or the guy wants a ton of money for it or whatever. But this one worked out pretty good. Judging by the weight that was involved here, and I didn't have a scale or anything, but I'd say we got it for scrap price. Bunch of round bar. He had aluminum and brass. I really wasn't interested in the aluminum, and he wasn't selling much of the brass. But a lot of his pieces were like 20 foot, had a hunk of bar that was like, 4 inches in diameter and 20 feet long. It's like, man, how do you even put that in your truck, So we left a lot of that there, and we picked through the drops. Well, Inspector Billy has come out to check out the haul, and here's what we got. Lots of nice alloy round bar, a nice super chuck, and oh baby, it looks like about an 8-inch chuck that'll plug right onto my lathe. So yep, not a bad haul for 2 hours driving and a couple of $100. So I'm going to move this into the shop and check some stuff out. I mean, obviously these chucks are going to need some evapor rust, but they're looking real good. Quite the deal. Alright, well, we're back in the shop here, and I took this chuck apart, and it had a backing plate on it, and this backing plate will not fit my lathe, but is possibly could be bored out. I gotta make some more measurements. Possibly could be bored out and threaded to fit my lathe. If not, just make a new one. But what was really interesting was this marking right here. An iron cross. I don't know. There's no other markings on this truck other than a T right there, and underneath the backing plate, an iron cross. The jaws are marked CJ4. That would be jaw 4. CJ1. And then a 47 after them. 47. The other thing is, it's weird. It's 9 inches. It's 9 inches across from here to here, which will swing on my lathe. But yeah, I was kind of shocked to see that. It's not so bad. It's got some cancer around the edges here where it looks like they were banging it up against something. I don't know what that's all about, but that'll stone out of there. I don't know what you call them, the ways or whatever, they're in pretty good shape, and so are the jaws. There was one piece that was busted. One of the screws, it's supposed to look like that, and this one has the end pulled off of it. So I don't know if that's going to actually make a difference or not in the performance of this chuck, but I may fix this. So, but yeah, so I'm going to throw this thing in some Evapor Rust and see how clean I can get it, and then we'll see about making another adapter here, or modifying this one to fit. But yeah, that was pretty shocking seeing that. I don't know if that means it was like World War II stuff or what. Here's the cart, and man, let me tell you, this is scary heavy. I don't even want to put it on my crane scale because I might rip the hoist out of the ceiling. But there's a nice chuck here. I'm going to take this off of this thing and clean it up too with that Evapor Rust, and see if I can put this on my lathe tail stock. But yeah, that's, it doesn't look like much, man, but that's a ton of weight right there. Lots of bar stock for goodies. Okay, we've got to do a little faceplate turn here. So after I measured this thing, it's a really weird kind of a thread. It's M55 by 5.5 the thread pitch, which is it's not even a standard. So I mounted it on the faceplate here. It turns out that there is enough meat in this adapter to cut my 2 1/4 to 8 TPI thread for the spindle here. So I mounted it on the faceplate with some clearance behind it so that the threading tool can make it through there, and I can also cut this register. And the way I got it centered up was use this belt center, come in here and get a basic center on it like that, and then I took my dial indicator, and there's one machine surface right here where it interfaces with the chuck. So I just ran it around there and tapped it until it straightened out there. So it's running within 1,000th. I'm going to set up a boring bar and bore this thread out of here, get it to the proper pitch, minor diameter for my lathe thread here, and then we'll set up a boring bar with a threading tool on it and cut the 2 1/4 8 thread. Okay, got a shop towel down here to keep these this cast iron dust off my ways, and we're about to start cutting here. Taking 20 thousandths cuts here. We've got a little ways to go here, but I want to make a little measurement, see where we're at. My minimum diameter here for 2¼ 8 internal is 2.11. So let's see where we're at here with our okay, we're right at 2.0. So take another 20. Okay, that old thread is almost gone now. So I'm just going to bore this out to the minor diameter and get set up for threading, and we'll bring you back then. Okay, so I wanted to show you how I did this setup. Basically, I've got my compounder in 30 degrees. You know, if I went this way, it'd hit the faceplate, so I had to turn it around the other way. Then what I did is I leveled this bit in here. Then I set it on center height. And then I clamped it parallel to my faceplate because I know that this faceplate is perpendicular to this bore here because I just bored it on there. And I took my fish gauge, I butted it up against the parallel, and I set the rotation here so that this was perpendicular to the bore. So now we're going to set up the gearbox for 8 threads per inch, and we'll be jamming here. Okay, so before we get started here, I wanted to show you this. Back in the old days when I first got this lathe, I made this, which is basically a perfect copy of my spindle. And I can use this to check the fit of anything that I make that's going to screw onto that. It's a real close tolerance thread. I should have made it out of steel, but I made it out of aluminum because that's all I had at the time. But this will come in real handy when you're trying to turn the register and the threads and everything. You can use this to check whether you're boring it right without having to take it off the lathe and try it on the spindle. It just saves a ton of time. Okay, so I'm ready to turn this thread. I glued the inside of it so I could see it a little better, and I got my 8 TPI thread gauge already here. So what I'm going to do is make a scratch pass, make sure everything's going right, and then cut the thread. The first thing I'm going to do is touch off. Okay, I set my DRO, set my zero on this gauge, this dial, set my zero over here, and I'm going to put a cut on. 5 thou. Here we go. Zoom it in. Take it out. Put it back to 0. Okay. Now what I'm going to do is measure this, make sure we are actually cutting 8 threads per inch, and we are. So we are going to jack on 7 thousandths. I think we are going to flap wheel this. Okay, flap wheel the inside of this thing a little bit. And now screws on nice right to the register. Okay, right there. So now what I got to do is just cut a little off the inside here, about 30 thousandths. And this baby will be done. So I got to swap out, I got to put a boring bar in here, and then we can cut this register. Alright, we're running out of batteries here, so I gotta make this quick. I finished it, and goes right on perfect. Let's see. I don't see any run out there, but I'll check it, and then I'm gonna hook it back onto the chuck. And oh, it goes on good. Okay, well, hey, we'll see you in a few minutes when I change the batteries. Seems to be good. So there we go. That was a pretty good find. Looks like they were rolling this thing on concrete, so I'm gonna have to probably touch the OD of this up with a tool, and then I'm gonna throw this thing in Evaporust. Now, I got this one screw I'm gonna have to repair, but other than that, this thing is cool. Alright, well, here's the final version of this chuck. It wasn't very easy getting it to run true, but it turns out that I guess they cut the back of this chuck to match the backing plate, and there's only one position where it actually, you know, runs true. Everything else is a freaking nightmare. But we got this thing dialed in within a thousandth, actually way less than a thousandth. And out here on the piece of this Thompson rail, it's running maybe a thousandth. So that's over like maybe 5 inches. And that's as good as it's going to get without doing all sorts of fancy stuff to it. But that's perfect for what I need. I didn't even put this in Evaporust. I basically cleaned the jaws with a wire wheel and mounted the chuck on here, and actually took a skim cut across just to true it up. It was a little bit out, probably 4 or 5 thousandths, so now it's running true with the lathe center. And then I took the jaws out and faced it and redid these grooves in here. So now she's a runner. Excellent. So this chuck pretty much didn't cost me much of anything except time and, you know, a lot of standing in front of the lathe making it happen. But it's a good addition to the tool arsenal, and you'll be seeing this thing in some upcoming videos. So once again, thanks for watching.